Imagine you are the chief organizer for a large multi-day wedding event. The success of this grand affair with its hundreds of moving parts rests entirely on your ability to plan meticulously and control the execution flawlessly. This, in essence, is the world of production planning and control, or PPC. Let's break down this analogy. The planning phase is everything you do before the event. Months in advance, you forecast the number of guests. This is your demand forecasting. You book the venue, ensuring it can hold everyone. That's capacity planning. You work with the chef to decide on the menu, creating a detailed list of every single ingredient needed, your bill of materials. Finally, you create a minute-by-minute schedule of events for each day, from the arrival of the barat to the final farewell. This is your master scheduling. This entire strategic and tactical effort is production planning. Then comes the wedding day. This is the control phase. You are on the ground, clipboard in hand, making sure everything happens precisely according to your plan. You check if the caterer has arrived on time, if the decorators are following the exact design, and if the ceremonies are starting as scheduled. If 100 extra guests suddenly show up, you don't panic. You work with the caterer to arrange for more food, adjusting in real time. This is production control. Therefore, PPC is the brain and central nervous system of any manufacturing operation. It is the formal, structured process of deciding which products to make, in what quantities, by what date, and with which resources. And crucially, it doesn't stop there. It involves executing that plan, constantly monitoring the results, and making intelligent adjustments to achieve the company's goals with maximum efficiency and minimum waste. Production planning isn't a single activity, it operates on 3 distinct levels of altitude. At the highest level, we have strategic planning, looking out over a long-range horizon of 2 to 10 years. This is where the big foundational questions are answered, setting the course for the entire company. Where should we build a new factory to enter the European market? What new product lines, like hydrogen-powered vehicles, should we launch to compete in the next decade? For instance, when Tata Motors decided to invest thousands of crores in a new electric vehicle manufacturing plant in Gujarat, that was a monumental strategic production planning decision that will shape their future for years to come. Next, we have tactical planning, which operates in the medium range of 6 months to 2 years. This is where strategy is translated into concrete production numbers, a process often called aggregate planning. The key questions here are, how many total units across all car models should we produce each quarter? Do we need to hire more workers or schedule overtime to meet the festive season rush? Should we build up inventory in anticipation of a price increase in raw materials? A smartphone company creating a master production schedule, or MPS, that specifies producing 500,000 units in the third quarter and 700,000 in the fourth, is making a critical tactical plan. Finally, we have operational planning and control, the ground-level, short-range execution that happens daily or even hourly. This is where the plan meets reality. Which specific job should be run on machine A right now? What is the hourly production target for assembly line B? How do we immediately adjust for an unexpected machine breakdown or a quality issue? This is the domain of the shift supervisor, using a digital dashboard to track output, manage queues, and reassign workers to cover for an absent colleague, ensuring the day's target is met. Effective PPC is a closed-loop system, a continuous cycle of learning and improvement. You plan to make 1,000 shirts. You execute the production run. You measure the output and find you only made 950. You control by investigating the shortfall, finding a 30-minute machine stoppage was the root cause. You adjust by fixing the machine and adding 50 units to the next day's plan. And most importantly, this learning is fed back into the system, perhaps by updating the machine's preventive maintenance schedule or retraining an operator. This constant feedback loop is what separates good organizations from great ones, allowing them to become more efficient and resilient over time. The challenges of production planning change dramatically depending on the manufacturing environment. Let's explore the 2 extremes. A job shop, like a custom furniture maker in Jodhpur, and a continuous production system, like a petroleum refinery in Jamnagar. Imagine the job shop as a high-end tailor's workshop. Every customer is different. They want unique patterns, special fabrics, and custom fittings. The primary goal here is flexibility and meeting due dates. The key planning question is always, what is the optimal sequence of jobs to run on each machine to satisfy all our customers on time? Now picture the continuous production system as a massive hydroelectric dam. The goal is the absolute opposite: stability and maximizing uptime. The focus is on ensuring a constant, stable, and massive flow of product, 24/7. The key planning question is, how do we balance the flow and maintain our equipment to prevent any shutdowns, ever? Here, consistency is king. Let's dive deeper into the job shop. Picture a precision engineering firm in Bengaluru's Pune industrial area, making custom parts for aerospace clients. The planner's job here is a high-stakes game of three-dimensional chess. They face extreme product variety. One order might be for 5 complex titanium brackets, the next for a single large aluminum housing. Each requires different machines, tools, and operator skills. The core problem is the sheer complexity of scheduling. The planner's screen might show 50 active jobs, each with a different due date and a unique route through the factory. Deciding which job to prioritize on a machine involves complex trade-offs, often managed with priority dispatching rules like earliest due date or shortest processing time. Resource bottlenecks are a constant headache. The advanced 5-axis CNC milling machine is always in high demand, creating a queue that delays every other job. And high changeover costs, the time it takes to switch a machine from making part A to part B, are a major source of inefficiency that must be planned for and minimized. Now let's transport ourselves to the control room of a large-scale cement plant. The environment is the polar opposite. The primary challenge is maintaining process stability. The giant rotary kiln, where raw materials are heated to over 1400 degrees Celsius, must run continuously for months. Any fluctuation in temperature, feed rate, or fuel quality can ruin thousands of tons of product. Because the plant is so capital-intensive, uptime is everything. Financial losses from a shutdown are enormous. Therefore, production planning is almost entirely dominated by maintenance planning. The PPC team works hand in glove with maintenance, scheduling planned shutdowns months in advance. More importantly, they rely on predictive maintenance. IoT sensors on a motor might detect a subtle vibration pattern, allowing an AI algorithm to predict a bearing failure before it happens. Here, inventory is not a sign of inefficiency, but a strategic buffer, with huge silos of raw materials and finished cement ensuring the plant can run smoothly despite external disruptions, like a delayed shipment or a mine closure. Let's zoom back into that medium-term, tactical level of planning. Here we find one of PPC's most crucial processes, aggregate planning. To understand it, consider a farmer in Punjab planning for the next year. It's too early to decide exactly how many seeds to plant in a specific square foot of land. That level of detail is for later. Instead, the farmer makes a broader aggregate plan. They'll decide to plant roughly 50 acres of wheat, an aggregate product, for the Rabi season. They'll plan to hire 10 temporary workers, an aggregate workforce, during the peak harvest month. This is the essence of aggregate planning. It's the process of developing a tactical plan to best utilize an organization's resources to meet expected demand over an intermediate horizon of 3 to 18 months. The core objective is a delicate balancing act, finding the lowest cost way to balance market demand with your production capacity. It's a puzzle with many pieces: production rates, labor levels, inventory, overtime, and even subcontracting. To achieve this balance, managers have 3 pure strategies they can use, though in reality, they almost always blend them. The first is the chase strategy. Here, the production rate perfectly matches the demand rate. You produce exactly what is needed, when it is needed. Think of a shadow that perfectly mimics your every move. The method involves hiring and firing workers as demand fluctuates. While this keeps inventory costs near zero, it creates a highly unstable workforce, lowers morale, and incurs significant costs for hiring, training, and layoffs. It's a volatile and often expensive way to operate. The second is the level strategy. This is the opposite approach. You maintain a constant production rate and a stable workforce, letting inventory levels rise and fall to absorb the fluctuations in demand. Think of a steady river flowing at a constant rate, where the reservoir level, your inventory, goes up and down. This strategy is great for morale and avoids hiring and firing costs, but it can lead to massive inventory holding costs during low demand periods or potential stockouts when demand spikes. It's a stable but potentially costly strategy. The third and most common approach is the hybrid strategy, which combines the best of both worlds. A company might maintain a stable core workforce to handle baseline demand and then use overtime, temporary workers, or even subcontracting to manage the peaks. An FMCG company like Hindustan Unilever does this masterfully, maintaining a stable workforce year-round but hiring temporary staff and ramping up production shifts in the months leading up to Diwali to meet the festive demand surge. This provides a balance of stability and flexibility. Let's consider Coolbreeze Air Coolers, a company with highly seasonal demand. A pure chase plan would require them to constantly hire and fire dozens of workers, leading to huge labor instability costs. A pure level plan, producing an average amount each month, would result in massive inventory holding costs as they build up stock during the winter. The manager must analyze the total costs of both scenarios. Invariably, a hybrid plan, perhaps maintaining a level workforce that can produce 80% of peak demand and using overtime for the hottest months, will prove to be the most cost-effective solution, balancing the cost of inventory against the cost of changing production rates. Once the aggregate plan and master schedule are set, we need a system to translate that plan for finished products into a detailed schedule for every single component and raw material. That system is Material Requirements Planning, or MRP. MRP is a powerful computer-based system designed to answer three simple but critical questions for every component. What is needed? How many are needed? When are they needed? At its heart, MRP is a calculation engine. It takes the plan for finished goods, the independent demand, and explodes it, breaking it down into a detailed schedule for all its constituent parts, the dependent demand. It does this while intelligently checking what you already have in stock. Its primary goal is to ensure materials are available precisely when needed, not too early, which inflates inventory costs, and certainly not too late, which shuts down production. MRP systems are built on three critical data inputs, or pillars. The first is the Master Production Schedule, MPS, which dictates the demand for the final product. The second is the Bill of Materials, BOM, a detailed, hierarchical recipe listing every single part needed to make one unit of the product. The accuracy of the BOM is non-negotiable. If it's wrong, the entire plan fails. The third is the Inventory Records File, IRF, a real-time database of every item, including stock on hand, scheduled receipts from suppliers, and crucial lead time information. Let's walk through the MRP logic with a simple table lamp. The MPS calls for 100 table lamps in week 5. The MRP system works backward from this due date. Assuming a 1-week assembly time, it knows it must start assembly in week 4. This planned order release for 100 lamps in week 4 becomes a work order for the shop floor. This action then triggers the demand for all the lamp's components in week 4. Let's look at the lampshade. The system sees a gross requirement of 100. It checks the inventory file and finds 20 shades are already on hand. Therefore, the net requirement is only 80. If the supplier's lead time is 2 weeks, the system automatically generates a planned order release for 80 shades in week 2, ensuring they arrive just in time for assembly. It performs this same calculation for the base assembly, which in turn triggers demand for the lamp base and bulb holder. This MRP explosion continues down to the lowest level raw materials, like screws and wires, perfectly synchronizing all purchasing and production activities across the entire supply chain. This powerful concept has evolved over time. The original MRP only managed materials. Then came MRP2, or Manufacturing Resource Planning, which expanded to include the management of machine capacity and labor resources, creating a more complete closed-loop system that could check if a plan was even feasible. The final evolution is ERP, or Enterprise Resource Planning. ERP systems integrate the entire organization on a single unified database. An Indian giant like Mahindra and Mahindra uses an ERP system like SAP to ensure that when their MRP schedules the production of 1,000 tractors, the finance department can instantly see the cash flow implications, and the HR department can plan for labor requirements, all in one seamless, integrated system. So, we've journeyed from the high-level strategy of PPC down to the detailed calculations of MRP. We've seen how a company must choose the right planning approach, whether it's for the chaotic, high-variety world of a job shop or the stable, high-volume world of a continuous process plant. We've balanced the critical trade-offs in aggregate planning and witnessed how a digital system can flawlessly coordinate the arrival of thousands of parts. Now, it's time to apply this knowledge. The true test of a PPC system is not how well it follows the plan, but how well it helps the organization respond when the plan is disrupted. Imagine you are the head of PPC for a major Indian automotive component manufacturer. A sudden geopolitical crisis has caused the price of steel to double overnight, and a key international port has been closed, delaying shipments of electronic microchips by 8 weeks. How would you use your PPC systems to respond? In the short term, your MRP system would immediately flag the impending microchip shortage. You would use your operational control tools to resequence jobs, prioritizing products that don't use those chips to keep the factory running. You might work with sales to communicate potential delays to customers. In the medium term, you would adjust your master production schedule and aggregate plan, perhaps reducing the forecast for certain models and collaborating with engineering to find alternative chip suppliers. You would run cost simulations to understand the impact of the steel price hike and potentially adjust pricing. This is the reality of modern production planning and control. It is not just about making a plan, it's about having the systems, strategies, and intelligence to adapt when that plan inevitably collides with the real world. It is the dynamic, challenging, and vital function that turns strategy into reality, navigating uncertainty to deliver value, day after day. The mastery of production planning and control separates industry leaders from followers, enabling organizations to thrive in an increasingly complex and unpredictable global marketplace. As you continue your journey in operations management, remember that PPC is both an art and a science. It requires technical expertise, strategic thinking, and the ability to remain calm and decisive under pressure. Master these principles, and you'll have the tools to excel in any manufacturing environment, turning complexity into competitive advantage.